The first example is the trig example. So as you can see, the trig graph is shown. The first step is domain. So basically the trig equations, the domain is all real numbers. So what we do for graph sketching is we bound it. On this example, I'm going to bound it between 0 and 2 pi. So the graph looks like this. So we only need this portion, the red portion on the graph. The intercepts. So we have the intercept, so we put the cosine x equals 0, and then as shown on the picture, the cosine is 0. It's just a basic cosine graph. It's pi over 2 and 0 and 3 pi over 2 and 0. So the x-intercept would be pi over 2 and 0 and 3 pi over 2 and 0. We go to the y-intercept. For the y-intercept, we basically plug in 0 to our function and we get 0 and 1/2 as our y-intercept. And we go to symmetric. So as you can see, f of x is not equal to f of negative x, so we have no symmetric. For the intervals of decreasing and increasing, you see the graph, you see your function, and we use the quotient rule to get the first derivative of our function. And as you can see, you can get this is your simplified quotient rule, and as you can see, negative cosine 2 negative sine 2 is equal, it's just equal 1, and then the final format would be shown 1 plus 2 sine x, negative 1 plus 2 sine x, 2 plus sine x squared. So for the intervals of increasing and decreasing, we put the denominator less than 0. So we get sine of x negative 1/2. So we want to see where the sine of x is negative 1/2. As you can see, that's just the regular sine graph, and the sine of negative 1/2 is 7 pi over 6 and 11 pi over 6. So we need a sine chart. As you can see, here's our sine chart. So we find where our graph is decreasing and where it's increasing. As you can see, we have the points, which is 7 pi over 6 and 11 pi over 6. And we plug in points for our numerator and denominator of our derivative function, and then you have the whole thing, which is this for our decreasing negative infinity to 7 pi over 6, as you can see on the negative side of our sine chart, and 11 pi over 6 and infinity. They're all decreasing. And then the increasing interval would be 7 pi over 6 and 11 pi over 6. And for the max and mean, well, we've set our derivative equal to 0, so we have 7 pi over 6 and 11 pi over 6, and we plug that into our function. And then for the minimum, we get 7 pi over 6 and negative 0.5, and for the maximum, we get 11 pi over 6 and 0.57. And the concavity, as you can see, the first one is your f function, the second one is your derivative function. Now you need the second derivative. So first you need to use the power rule first, and you get your function set up like this, and then you use the chain rule, and that's how you set it up. And then the final format would be this for our second derivative. Now we need to set this equal to 0. So when we set this equal to 0, we find that sine of 1 is pi over 2 and 3 pi over 2. And we have a concave down, which is the maximum as shown on the graph. We have a maximum. The f double prime is a concave down, and then how it affects the graph is there's a maximum. That means it's from increasing to decreasing. And then we have a minimum. So the concavity interval would be 0 to pi over 2 concave down, and concave up is pi over 2 and 3 pi over 2. For the inflection points, we put our second derivative equal to 0, and then we plug that into our function. And here's the final graph with all the important features. As you can see, we have the x and y intercepts, a minimum at 7 pi over 6 and negative 0.5, and then the maximum at 11 pi over 6.